Okay, you need to get up to speed on large language models, LLMs for short,
Hmm.
and you need to do it fast. We've all been there, a big meeting on AI coming up, and you're drowning in research papers. But don't worry, that's where this deep dive comes in. Today, we're going deep on a fascinating Apple research paper that asks a very interesting question. How much do LLMs, like ChatGPT, really understand?
You see all these headlines about LLMs acing tests, writing code, even like composing music.
Right?
It's impressive stuff, but this paper digs into whether they're truly reasoning their way to these outcomes or if something else is going on.
Right, because on the surface, it seems like they're doing some pretty high-level thinking. So how did Apple's researchers decide to tackle this question?
Well, they started with a benchmark called GSM-8K, which is basically a standardized test for LLMs,
Hmm.
particularly when it comes to solving math problems. Think of it as a way to measure how well these models perform on a set of consistent challenges.
Makes sense. You need a measuring stick to track progress, right?
Absolutely.
Mm.
But there's a catch. Because GSM-8K is so widely used, there's a chance that some LLMs may have already encountered similar problems or even variations of them in their massive training data sets.
Mhm.
So are they really solving these problems from scratch, using reasoning, or are they just recognizing patterns they've seen before?
Okay, so it's like acing a test because you studied the answer key beforehand. Not exactly a sign of true intelligence.
Exactly. And that's where Apple's research takes a really interesting turn. They created a new benchmark called GSM-Symbolic, which builds upon GSM-8K.
Okay, here's where things get really interesting, right? Tell me more.
GSM-Symbolic uses the same fundamental math problems as GSM-8K, but it changes the presentation, the wording, and some superficial details.
Okay.
For example, instead of John has 3 apples,
Mm-hmm.
the problem might become Sarah has 5 oranges.
Mm-hmm.
The core mathematical concept is identical, but the details are different.
So same math, different outfit, I get it. But why is this so important?
Because if an LLM truly understands the underlying mathematical concepts, these superficial changes shouldn't matter. It should be able to solve the problem regardless of whether it's about apples or oranges. But here's the kicker. They do matter, and the results are pretty significant.
Wait, so just by changing John to Sarah, the LLMs started tripping up. That's wild.
It is, and that right there points to the possibility that many LLMs rely heavily on pattern recognition, not deep understanding. They might excel at spotting patterns they've encountered before, but when you throw a curveball like changing a name, their performance can become, well, inconsistent.
Okay, so just changing a name in a math problem is enough to throw off these large language models. It makes you wonder what else the Apple researchers threw at them.
Well, they didn't stop at just changing names. They wanted to see how LLMs would handle changes in uh, difficulty. Think about it like this. They took those math problems and either made them longer and more complex by adding extra steps or clauses, or they simplified things by removing information.
So, kind of like the difference between a basic math problem and one of those multi-step brain teasers that make you want to reach for a calculator.
Exactly. And what they found was pretty revealing and consistent across the LLMs they tested. As they made the problems harder, adding more clauses, those accuracy scores took a nosedive. But here's the interesting part. The results were all over the map.
All over the map. How? Did some LLMs do better than others? Give me the details.
Some LLMs would totally bomb a problem with a few extra clauses, while others would still manage to get it right. It was surprisingly unpredictable.
Okay, some handled the heat better than others. It's almost like these LLMs are showing individual strengths and weaknesses, just like human students. Some are better at those complex problems than others. Why do you think the researchers found this variance so interesting?
It's a great question. You see, if these LLMs were truly reasoning like humans, we'd expect to see their performance decline gradually as the problems got harder.
Right.
The fact that some aced the hard ones while others failed is a big clue that something else might be happening under the hood.
So we're back to this idea of pattern matching, right? If the LLM doesn't immediately recognize a pattern or a very similar problem from its training data, it's sort of left scrambling for answers.
You got it. And the researchers suggest that matching patterns within a massive data set becomes exponentially harder as those problems get longer and more complex. It's not just about having access to information, it's about being able to find the right information quickly and efficiently.
So maybe it's less about intelligence as we traditionally think about it, and more about how effectively these models can sift through their internal databases of information. But the Apple team had one more trick up their sleeve, and this one feels like a real gut punch to that LLMs understand everything narrative we hear so much about. They called it GSM-NoOp. That sounds a little ominous. What is it?
This is where it gets really fascinating. Imagine you're trying to solve a straightforward math problem, but someone throws in a piece of information that's totally irrelevant, potentially even distracting, even though it sounds important.
Like telling me that the kiwis are green. When I'm trying to figure out how many kiwis there are in total, why would you do that to me?
You're getting it. That's precisely the kind of curveball GSM-NoOp throws. The researchers wanted to see if LLMs could discern between useful information and noise that has absolutely no bearing on the solution. Can they tell the difference between what matters and what doesn't?
Okay, drum roll, please. Did the LLM sail through this challenge, or did they stumble?
Get ready for this. Adding those no-op statements, those seemingly relevant but totally useless bits of information, caused a huge drop in accuracy across the board. Even the top-performing models struggled.
Wow. How big of a drop are we talking about?
Some LLMs saw their accuracy plummet by as much as 65%. That's massive. It really highlights how sensitive these models can be to irrelevant information.
Okay, that's a big deal. Give me an example. How are these LLMs getting tripped up?
Of course. So in the paper, there's this one example involving someone buying school supplies, and, notebooks, pencils, erasers, the usual.
Very relatable. I feel like I'm constantly stocking up on those.
Right. Now, they threw in a no-op statement mentioning that prices were 10% lower last year due to inflation. But when you think about it, that has absolutely zero impact on how much the person is spending today. It's totally irrelevant.
Unless, of course, you happen to have a time machine and can pop back to last year for those school supplies. But for now, time travel remains in the realm of science fiction, unfortunately.
Exactly. But some of the LLMs, even those considered top performers like OpenAI's, fell right into that trap. They actually incorporated the inflation rate into their calculations, even though it was totally unnecessary.
So they were so focused on finding any pattern, any connection, that they kind of missed the bigger picture. It's amazing, but also a little worrying.
Absolutely. This finding suggests that while LLMs excel at recognizing and applying patterns and procedures, they can still struggle with what we humans might call common sense reasoning or critical thinking. There's a certain level of nuance they haven't quite grasped yet.
Which is why this research is such a big deal. It's like holding a mirror up to the field of AI and saying, we've come incredibly far, but let's stay grounded in reality. We need to acknowledge the limitations of these models if we want to create truly intelligent machines.
I couldn't agree more.
We've covered a lot of ground on the specifics of this Apple research, but you know what they say? It's not just about the findings, it's about the implications. What does this mean for the future of AI? And, more importantly, for you, our listeners. So we're back and ready to tackle the big so what. We've spent this deep dive exploring this Apple research that really digs into how large language models, or LLMs, solve problems. And it turns out it's not always in the ways we might assume. So what does this mean for the future of AI?
Well, for starters, it challenges us to rethink how we evaluate these models. As we've seen, just because an LLM can ace a test or generate impressive outputs, it doesn't necessarily mean it truly understands the task at hand.
It's like we've been giving LLMs a bit of a free pass, because they can do some really cool things, but maybe we need to raise the bar.
Exactly. We need to be much more rigorous in our assessments. It's not enough to just check if an LLM gets the right answer. We need to understand the why behind it. Did it get there through genuine reasoning, or was it more about recognizing patterns from its training data?
So how do we design better tests for these LLMs? What would a truly intelligence-proving test look like?
That's the million-dollar question. It's something researchers are actively working on, but it likely involves going beyond simple question-and-answer formats and creating scenarios that require genuine adaptability, creativity, and critical thinking.
So less about memorizing facts and more about applying them in new and unexpected ways. We need to see if LLMs can handle curveballs and think on their feet, so to speak.
Precisely. And that's where things get really exciting. By understanding the limitations of current LLMs, we can start to develop even more sophisticated and capable AI systems in the future.
This Apple research definitely has me thinking differently about the AI landscape. It's a good reminder that while we've made incredible progress, there's still so much more to explore and understand.
Absolutely. And the more we understand these models, the better equipped we'll be to harness their power responsibly and ethically.
So to our listeners, the next time you see an LLM doing something amazing, don't just take it at face value. Ask questions. Dig deeper. Challenge the assumptions. And most importantly, don't be afraid to be a little skeptical.
After all, that's what we encourage here on the Deep Dive. thinking critically about the world around us and pushing the boundaries of knowledge.
And on that note, we'll wrap up this deep dive into the fascinating world of LLMs. It's a field that's constantly evolving, and we're excited to see what the future holds.
Until next time, stay curious.
And keep those questions.